Yeah. Okay, glad it is working finally. I don't know, it took like 5 minutes to load the live. Um, so, good morning, everybody. Let's get this started. So, we are doing the N-Queens for all now. This is day 3, the first stretch. I don't know how many stretches I'm going to do, but yeah, and I'm having some cold. Don't mind that, and my eyes are really paining as well. But we gotta do this. So this is a code that we were stopped at yesterday. Yeah, okay. It's so we brief Alright. So it is n times n just board. So you are going to need an n times n just board, and you're going to write an eSave function boolean. If you give it like the value the row and column, it is going to check all the previous placed queens, and it is going to return if the queen is safe to place or not. That's it. Okay, recursion. If the recursion fails, that single line of code is like a loop but recursed. And if the recursion fails, it backtracks again. That is the base case if all the rows are filled. Then you print the board. Okay, come on. Board. Okay, same column check. Okay, so we are going to read our note. Okay. I'm having a runny nose as well. God. Queen's problem. So let us draw 4 chessboard and oh, wow. I'm very great at drawing straight lines. This works. Yes. So this is a 4 chessboard. Let's say you place your queen here, and you need to check if there is a queen here. And if you place your queen here, right, there is a clash, but doesn't matter. Let's say you place your queen here. You need to check for here, here, and here. How do you access these things? For I is equal to 0. So I is iterating here. I is equal to 0. I less than rho. So this is going to be, what is the index of this one? 0, comma 3, 1, comma 3, and 2, comma 3. So the column is fixed. Yep, the column is fixed. And you are iterating through the board. Okay, nice. And if you place your queen here, you need to check these 3 boxes as well. This is like 3, comma 3. So you also need to check 2, comma 2, 1, comma 1, 0, comma 0. So you need to start from row minus 1 and column minus 1. And I greater than or equal to 0, j greater than or equal to 0, since this is a left diagonal. I minus minus, j minus minus. If is place, right? Place is a function. Okay, board is a function. Okay, nice. And consider this example. You need to check these, right? This is the second row, first column. So for 2 comma 1, you need to decrement it and you need to increment it. You need to decrement it and you need to increment it. This is 1 comma 2 is this one, 0 comma 3 is this one. So that will check the right diagonal. So how will you do this? You are decrementing the row. I is equal to row minus 1, j is equal to column plus 1. Is that it? Yes, it is it. I greater than or equal to 0 is the case and j less than or equal to n. Okay, less than n, not less than or equal to. You you are decrementing this one and you are incrementing this one. If bored, you are going to return false. Nice, man. You have understood it. This is the core. And then the recursive function. So I'll try all columns, okay. Yes, sir. For row column. Proper format and no changes. So you need a board and you need a number of queens. Alright. So you need a board and you need the number of queens. Okay, all the three conditions we have discussed here. If that's not the case, we will return the true. That means it has not passed through any of these for loops. I mean, any of these if conditions. It will pass through for loops. So print board, okay, you will print it using the ternary operator. And what are the return types? It is going to return boolean and it will take row and column. Okay, and solve. Okay, now. Okay. God. Okay. Now 8 p.m. Okay, almost 11 hours, but we are good to go with the free version. 3 phases. Try. Go deeper. Nice. Okay, place my queen. Next queen. Full solution is one. An extra gets stuck, repairs and returns without printing anything. Okay. Okay, row or column if you got it, man. Got it. Now I have actually understood the flow. Let's do it like this. You are here, and okay, you will start here, and you will print it. The place gets 0, right? Okay, wait. Okay, I thought I understood it. Okay, you are placing a queen. Row plus 1. Okay, you are going deeper. Okay. Okay, 0, 0, you will place the 1 and you will solve the 1. Solve row 1. If row 1 fails completely, you fall. And solve returns to solve 0. Okay. I'm going to try run it. Let's say place it here. And then you will start here. Nope. Then you will start here. Nope. Then you will start here. Yes. And then you will start here. Nope. You will start here. Nope. You will start here. Nope. Okay. No. 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 And no. So this is a no as well. So you will place it here. And then no. Yes. Yes. Wow. Okay. No. And no. And no. And no. So this is a no. This is a no. This is a no. So this is a no as well. So this is a no. This is a no as well. Oh, this is the art of backtracking. And then you will start from here. No, 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 yes. And then again, yes. No, okay. Why does it care? No, no, yes. This is a solution. Okay. Okay, got it. Got it. Okay, regression explores all ranges. Okay, tree of choices. Suppose the regression printed, okay. Think of it like systematically walking through every possible placement combination, but only going deep when safe. Backtracking ensures nothing interfaces with the next trail. Tag friends, remember, I placed a queen here, I still have other columns to try. Backtracking length up, okay, done with this column, let's try next. Cool, dude. All valid leaves. Right now, I'm kind of understanding where this thing is going. So, I jar the indices. Print board. Okay. You are printing the board. This is a backslash, and after the row gets placed, and this is the backslash, and after the entire solution gets placed to have space for another solution. So solve. This is the base case, and if it is safe at a row, place it and solve. Okay, so we are iterating through columns. Okay, we are iterating through columns. These are columns, right? So in the first column, we place it. If it is safe, yes, it is safe. Then you explore here. Then nope, yes, nope, and yes. So then it will explore here. So what are you doing? Row plus one. You are updating the rows by going through the columns. And when you hit a dead end, you will backtrack here to this place. You will backtrack. Try all the possible solutions. Recursion does all the work for you. Recursion does all the work for you. All right. Yes, I need to replace it. Ouch. So if we are able to write the code for this sequence problem, then I will take a small break. Yeah, I mean writing the code is not a profile analysis. What? No, I swear I have seen something. What is profile analysis in this? Okay, I guess I need to learn this. Alright, so right, so I remember having a place. Okay, place is something that got in my mental mind, not that. Okay, so you are okay. So what are you trading through? Let's say you got a queen at a you got a queen at here. You need to trade through this two. Where are these? What is the index here? 3, 2. So you need to iterate through 0, 2, 1, 2, and 2, 2. You need to iterate through this. So what are you doing? Column stays fixed, and so I less than row I plus plus if mode of high column alright. Now you are decrementing the I and incrementing the J. Right. We need to take the right diagonal, right? That will be no, this is rho minus 1. That is called plus 1. And you are decrementing I. That means yes, since it is 0 based indexing, it is greater than or equal to 0 and it is less than. You are decrementing and incrementing this. If it didn't go through, yeah, this you are going to return true. Oh God. Okay, and print board entire image. Obviously, you need the header item variables for. Okay, does it take parameters? Yes, it takes parameters. If you have a, if the board of I, J, I can write it directly. Person, I'll say. Um, board of I, J, if it is 1, then printf q, else you will printf dash. Okay. After printing the row, you are printing the backslash n, and after printing the board, that is it. And now solve. So what is solve returning? Since it already have a so if all the what happened, if all the rows are filled, then you will print board. You can write in okay. You can write a counter here. Personally, so that is solution 1. It prints solution 1 and it print the board. Does print board take any arguments? Okay, why is not print board taking any arguments? Okay, why? Since it is, you already know the dimensions, right? So this is just waste. You already know that. All right. If that is the case, you need to return the control to there. So else, for every column, we're trying to solve, right? Right, I less than column. Okay, you're only supposed to take one argument over here. Why? You need to solve. You are solving rows. Okay. Okay. You only solve for a row. You try the column between 0 to n. Okay. So you are iterating through every column. If if now you have your row and column. If it is safe, board board of row and column will be placed with 1. Okay, and then you will solve this for the next row. You will repeat this for the next row. If that is not the case, board of row and column will be 0. Right. I don't know. This is basically backtracking. That is it. Void main. Okay. It is a global variable, right? So everything gets updated. Call this solve. Call the solve row. That's it. That's it. Sorry, I need to replace it. Very good. Okay, it's not call, it's column. Same with others. Instead I will do this. Obviously, column plus plus. What the? I did something. I did something. Counter is always 0. Why is it always 0? Okay. Counter should be declared. Okay, every time. And what did we get the output? Solution 0, solution 0. Okay. So let's write this somewhere above. Right. The scope of variables, that's why it is very important. Backtracking not directly inside if solve row plus 1 runs even if is false. Okay. Okay. If it is, oh my god. If it is safe only, you need to go to the next one. Just because of the fact that I know you can write one line ifs. I have written this. If it is safe, place the queen and go. Does that work? Comma operator. This does not work as intended. Both expressions. Okay, this is wow. Nice, dude. Nice. This should make a whole lot of difference. Yes, sir. Yes, sir. We have did it. We have did it. We have did it. Nice. 92. can print any number of wins now. 43 minutes, I say. What is next on our checklist? Okay, it cannot open our documents. This is a search it, I see. Right, that's great. So what's next in our bucket list? And Greensboro, we have done it. Backtracking for knapsack. I have learned the DP version of knapsack. All right. Okay. Knapsack of Australia, next we'll do. That's it. What the heck? All items are considered. Okay, now I have understood only our teachers complicate problems. These are not really that difficult. Should I be sleeping for an hour? It's very cold. I guess I will put some steam. Since we have successfully solved the Queen's problem, I will get back people for this knapsack by backtracking. Have a great day. I will come back after some steam.